Hi, this is Alex from devstories.eu. Snowflake and Snowpark Python, Episode 8 of 17. Scaling an existing Pandas pipeline traditionally meant throwing away your code and rewriting everything in a distributed framework like Spark. What if you could handle a dataset 100 times larger just by changing a single import statement? That is the premise of Pandas on Snowflake. Pandas is the universal standard for data manipulation in Python. It is expressive, readable, and deeply ingrained in how data engineers and scientists work. The problem is that Pandas is fundamentally constrained by single-node execution. It requires all your data to fit in local memory. When your dataset outgrows your laptop or your cloud instance, standard Pandas breaks. Pandas on Snowflake represents a complete paradigm shift for these legacy pipelines. It acts as a zero-friction migration tool. Suppose you have an existing Python script that cleans and aggregates daily transaction logs. It works perfectly on 10 gigabytes of data, but suddenly you are asked to process a terabyte. To scale this, you do not need to rewrite your logic into SQL. You do not even need to learn the specific syntax of the standard Snowpark data frame API. You only change one line at the top of your file. You remove the standard import pandas as PD. You replace it with import snowflake.snowpark.modin.pandas as PD. This is where it gets interesting. A common point of confusion is how this actually processes data. Many developers assume this is just standard Pandas operating on a live connection, pulling millions of rows down to their local machine to process. That is incorrect. When you use this specific Modin import, no data is downloaded to your machine. Instead, this library intercepts every Pandas command you write in your script. When you chain a filter, a group by, and a mean aggregation, the underlying engine translates that exact sequence into an optimized Snowflake SQL query. It transpiles your Pandas syntax into SQL and then submits that SQL to the Snowflake compute engine. The operation executes entirely inside your Snowflake warehouse. Your local machine is only responsible for orchestrating the commands. The heavy lifting is distributed across Snowflake clusters. This gives you the exact developer experience of Pandas, but backed by a massively parallel database. This shift solves two major organizational headaches at once. First, it eliminates the data egress problem. Because the operations are pushed down to the database, your raw data never leaves the secure Snowflake perimeter. Second, it saves months of developer retraining. Your team continues writing the familiar data frames, joins, and aggregations they already know perfectly. They just run them against the cloud instead of their local processor. The true power of Pandas on Snowflake is that it decouples the language you use to describe your data transformations from the engine that actually executes them. If you find these technical deep dives helpful, you can support the show by searching for DevStories EU on Patreon. That is all for this one. Thanks for listening and keep building.